All right, proving lines parallel. This lesson is very much the opposite, or as we'll see, the converse of our previous lesson of parallel lines and transversals. Today, we are going to define, as I said, the converse of these postulates and theorems. The first thing we'll look at is the converse of consecutive same-side interior angles postulate. This says that if two lines in a plane are cut by a transversal so that a pair of consecutive angles is supplementary, and actually I forgot to put interior angles, consecutive interior angles, is supplementary, then the lines are parallel. This is different than yesterday, because yesterday we said if we have two parallel lines, then consecutive interior angles are going to be supplementary. They add up to equal 180. Today we're saying that if we have two lines, we're not saying they're parallel, but if we have a transversal and these two lines are supplementary, then the lines are parallel. So yesterday we talked about lines being parallel, so the angles were supplementary. Today we're saying the angles are supplementary, therefore the lines are parallel. All right, and we've got the same converse for each of those four postulates that we looked at yesterday. Alternate interior angles postulate. Two lines in a plane are cut by a transversal. So basically, if alternate interior angles are congruent, then the lines are parallel. Make sure I get it all in there. Okay. And the next one says that if alternate exterior angles are congruent, then the lines are parallel. And the last one, if corresponding angles are congruent, then the lines are parallel. So today we're not proving angles congruent, we're proving lines parallel. That's the difference between what we did today and the day before. So we have our first question. It tells us that angle 1 is congruent to angle 5. That means angle 1 and angle 5 are congruent. So first, let's identify which lines we're talking about. We're not looking at this line. This line has nothing to do with what we're looking at. And we'll find that we see that these two lines right here are cut by this transversal. And angles 1 and 5 are corresponding angles. So can we prove that these two lines, L and N, are parallel? Well, remember what our postulate says. If corresponding angles are congruent, then the lines are parallel. This says that corresponding angles are congruent. Therefore, L is parallel to N. How do we know that? Well, we know that by the converse of corresponding angles postulate. This right here. Okay, let's look at the next question. It says that the measure of angle 4, again, remember, we're proving lines parallel on these questions. It says that given that M is equal to 105, so let's look at this. We're going to, sorry about that. M is 105, the measure of this angle right here. And the measure of angle 5 is, what is it, 70? Can we prove anything parallel? Well, you'll notice that these two lines are cut by this transversal, and angles 4 and 5 are consecutive or same side interior angles. And if lines are parallel, those consecutive interior angles are supplementary. Well, let's see. 105 plus 70 equals 175. That is not 180 degrees. That means since 4 and 5 are not supplementary, then M and N are not parallel. So the question, is it possible to prove that any of the lines are parallel? The answer would be no, impossible. All right, next question. It says find Zn. Let me get some erasing in here. Yeah, my eraser's not working. Oh, that's all right. We'll go with it. Find Zyn, which is Zyn is right here, so that PQ is parallel to line PN. So we've got this line and this line cut by this transversal, and we're trying to prove lines parallel. Well, we can see that this angle and this angle are exterior angles, and they're opposite sides of the transversal, so those are alternate exterior angles. And we'll remember, if lines are parallel, they are congruent. So 11x minus 25 is equal to 7x plus 35. Move this up. So let's solve for x. Subtract 7x. 4x minus 25 equals 35. Add 25 to both sides. 4x equals 60. That means that x equals 15. So what would Zyn have to be in order for this to be the case? Well, x, for lines to be parallel, x would have to be 15. Here's Zyn, so that means 7 times x, which is 15, plus 35. 7 times 15 is 105, plus 35 equals 140. So the measure of angle Zyn would have to be equal to 140 degrees in order for those two lines to be parallel. All right, let's look at the... It asks a question here, can we use this information in the figure to conclude that P is parallel to Q? Well, if we've got this angle, and then we've got this angle. Actually, let me zoom in on this. One is interior, one is exterior. They're on opposite sides. They're not corresponding. They're really not any of these, any of the four that we've been looking at. However, if we could make 71 equal to something, then we would be able to, if we can find what 71 is equal to, for instance, look at angle 3. It is vertical to that angle. Angle 3 is 71 degrees. Now, by doing that, we have these two lines with this transversal, 71 and 109. If they add up to 180, then lines P and Q are parallel. Well, 71 plus 109 equals 180. Therefore, the question asks, can we use the information to conclude? We can say yes. Consecutive, and the converse of consecutive interior angles are supplementary. Or we could just say the postulate. Okay, we have to make sure that we're able to identify the 4 different types of angle relationships, such as same side interior, alternate exterior, and corresponding. If we can do that, on top of knowing that vertical angles, identifying vertical angles and supplementary linear pairs, then we should be okay for this chapter. Okay, and that's all.